All right, today we're diving into one of the most genuinely unsettling ideas in all of physics. So let's just jump right in with a question that honestly sounds completely absurd. What's more likely to just pop into existence out of pure chaos? An entire universe? Or just your brain? Yeah, just your brain floating in space, complete with all your memories. Which one is the bigger long shot? You might be surprised by the answer. Now, to even begin to answer that, we need to wrap our heads around one of the most fundamental rules of the universe. Seriously, this thing governs everything. And that concept is called entropy. You can think of it as basically a scientific measure of disorder, of randomness, of chaos. The messier something is, the higher its entropy. And here's the key part, the second law of thermodynamics. It's a huge deal. What it says, basically, is that the total messiness of the universe is always going up. You know, things don't get tidier by themselves, right? The universe's natural tendency is to go from order to chaos. Let me give you an example. Imagine a neatly stacked deck of cards. That's a state of low entropy, right? It's super ordered. But what happens if you throw them up in the air? Boom. Instant high entropy, instant chaos. Or think about a sandcastle. It takes effort to build. That's order. But a pile of sand? That's the easy, chaotic state. Order is just way harder to achieve than chaos. So what this all means is that statistically, there are just so many more ways for things to be messy than for them to be neat. The universe just defaults to chaos because it's the path of least resistance. Order is the real statistical fluke. And that brings us right back to that weird question from the beginning. So we've got our incredibly ordered universe on one side and a single ordered brain on the other. Both are pockets of order in a universe that loves chaos. So, which one is the bigger statistical long shot? Okay, let's actually put them side by side. The universe, that's a massive, incredibly complex system with billions of galaxies all humming along. That is an extremely low entropy state, a huge amount of order. Now, a single brain? Don't get me wrong, it's complex. But compared to the whole universe, it's a much, much smaller blip of order. And here's the absolute core of the argument. Physics tells us that smaller fluctuations away from chaos are exponentially more likely than massive ones. Think about it. If you just waited for random molecules in the air to bump into each other and form something, what's more likely? That they form a little teacup for a split second, or that they form a perfect two-scale replica of the Eiffel Tower? The teacup, right? It's not even close. Smaller flukes are just way more probable. So you can see where this is going. If creating an entire universe is like winning the Powerball jackpot, then creating just a single conscious brain is, well, it's still like winning the lottery, but maybe just a scratch-off ticket. It's still incredibly unlikely, but it's way, way, way more likely than the jackpot. And this is where we get to the really disturbing conclusion. The logic says that a single conscious brain is statistically far more likely to just appear out of chaos than our entire universe is. If you're an observer, the odds say you should be the smallest possible observer. Just let that sink in. It is more probable that you are just a momentary disembodied brain than a person living in a real, vast universe. This isn't some sci-fi fantasy. It's a conclusion that seems to follow from the laws of thermodynamics. And of course, this hypothetical lonely consciousness has a name. It's called a Boltzmann brain, named after the guy whose work on entropy kind of started this whole mess, Ludwig Boltzmann. And the implications here are, well, they're terrifying. It means your memories of the past, they're false. The world you see around you, not real. The people you love, they don't exist. You just fluctuated into existence a moment ago, and you are completely, utterly alone. So, is that it? Is this what physicists are telling you, that you're not real? That none of this is real? No. Phew. In fact, it's pretty much the opposite. You can breathe now. Modern cosmologists don't actually believe we're Boltzmann brains. Instead, they use this whole paradox as a really powerful tool. It's like a reality check for their theories about the universe. So here's how they use it. It's pretty clever. You come up with a new theory about how the universe works. You do all the math. Then you ask, what does my theory predict? Does it predict a universe full of observers like us living on planets? Or does it predict a universe dominated by lonely floating Boltzmann brains? If your theory says there should be way more lonely brains than people like us, then your theory is probably wrong. It gets tossed out. So the whole point is this. A good theory of the cosmos has to predict the universe we actually see, right? We know we exist. We know we're in this big, complex universe. So any theory that says, nah, you guys shouldn't be the norm, these lonely brains should be, well, that theory has a serious flaw. And that kind of leaves us with one final, big thought to chew on. If a theory predicts we shouldn't exist, is the theory wrong, or are we? It's this deep question that the Boltzmann Brain paradox forces us to ask. It's a reminder that when our best science seems to contradict our own reality, it probably just means we have a lot more to learn.